Welcome back. So now we're going to be performing some transformations using vectors and matrices and notating them in the correct notation. All right, so coordinate representation of translations. You can use formulas when the translation occurs in the regular coordinate system, and that's our coordinate plane, and that's what where we're going to be doing most of our transformations, most of our translations. Sometimes we do them off the coordinate plane. So a property of a translation in a coordinate system. A translation is a function from the plane to the plane. So it keeps it in the coordinate plane such that every point x, y corresponds to point x plus y, y plus b, where a and b are real numbers. In other words, we're going to take every point on our figure, on our pre-image, and move it the exact same distance horizontally and vertically. Right, so we want to find the coordinates of the image of the vertices of quadrilateral ABCD in the figure below under the translation given, and we're going to draw the image. Right, so here we have it in coordinate notation. XY goes to x plus 2, y minus 3. I could also write that, I think that's going to come up, in vector notation. Come on, words. I don't see any words. The moment I write over it, it's going to appear again. I know it. Right, so in vector notation, come on, words. It would be 2, negative 3. Let's see how long it takes to come up. Anyway, while that's thinking of coming up, I told you it would come up twice. Maybe 3 times. Let me erase this and I'll write it nicer. Always takes the longest to start writing the first time. All right, so that's how we would write it as a vector. All right, so now we're going to use a matrix to be able to find our coordinates. And this works really nicely because it's easy to get lost counting, especially if the coordinate plane is small. All right, so for a matrix, this, by the way, and you're going to put this one in your, no, this one's on your notes, but the next one, you'll write these in your notes. And so the matrix here just shows you the x and y coordinates of our figure. Right? So all the x coordinates are along the first row, all the y coordinates along the second row, and then we have each point listed. So point A is point A is located at negative 7, 4. Point B is located at negative 1, 4. Point C is located at negative 1, 7, and point D is located at negative 7, 7. This is my 7 here isn't that great, so let's fix that up a little bit. Right? And so now we want to translate our figure. So what we're going to do is we're going to add the vector to the x and y coordinates. And when I write it as a matrix, I'm always going to have the x in the numerator, or not the numerator, x in the top and y in the bottom. Right? And so we're always changing our x coordinates according to the rule for our x there, either the vector in vector notation or coordinate notation, and we're always changing y according to the y part of our rule or vector. Right? So we're going to, according to our rule or our vector, we're going to add 2 to all of the x coordinates. We're going to add negative 3 to all the y coordinates. And then when we add them, when we combine those two matrices, we're going to have the coordinates for A prime. Come on. A prime. Let's see if I can remember where I wrote. There we go. B prime, C prime, D prime. Just trying not to write over my handwriting again, because I knew it would appear. Right, so you need to be able to notate a transformation in coordinate notation and vector notation. And then you also need to be able to use matrices to find your coordinates. Right? So you need to be able to use all of our different representations. So negative 7 plus 2 is negative 5. Negative 1 plus 2 is 1. Negative 1 plus 2 is still 1. Negative 7 plus 2 is negative 5. And now I'm going to add negative 3 to all the y coordinates. 4 plus negative 3 is 1, and still 1. 7 plus negative 3 is 4. And so now, without having to sit there and count, especially, which can be difficult when it's on a very small coordinate plane, is that 4 going to come up? Or if we even go off the coordinate plane, well, oh, there it comes. Right? By using matrices, we have all of our points. So it's really essential that you be able to use a vector and a matrix to find your points. Right, so let's find all of our points. We have -5, 1. Right, so this is where A prime is located. And then we have 1, 1. And this is where B prime is located. And 1, 4. And there is C prime. And then last but not least, -5, 4 is D prime. And so now I'm just going to connect my points. And now we have graphed our image. And every point went the exact same direction. It went 2 in the positive direction, horizontally, and 3 in the negative direction, vertically. Okay? In other words, 2 to the right and 3 down. All right, let's do another one. I think it's the next one that's in your notes. I think it is. I don't know. This one I think is the one in your notes. All right, so I don't think I have the matrix in your notes. So you want to write down that matrix that's shown there, and that's just the coordinates for the triangle ABC. We're going to add the vector to it. Right, so here we have in coordinate notation. In vector notation, that would be 2, -1. And to each of the x coordinates, we're going to add 2. To each of the y coordinates, we'll add -1. And when we do that, we will have, oops, I just dropped my pen. We will have A prime, B prime, C prime. That's it. This one's only a triangle. It only has 3 points. All right, so -4 plus 2, that's -2. -3 plus 2 is -1. -1 plus 2 is 1. 2 plus -1 is 1. 4 plus -1 is 3. And some reason my 1 has dropped it all the way down there. But 1 plus -1 is 0. All right, and so now we've added the x component of our vector to all the x coordinates and the y component of our vector to all the y coordinates. And now we can just graph our figure. All right, so -2, 1. So here is A prime. And then we have -1, 3. There's B prime. And 1, 0 is going to be C prime. And now all we have to do is connect our coordinates. And there we go, our figure is graphed. Right? And that's all there is to it. Right? So you're just going to take your coordinate notation, or if it said to write 1 down, right? You're just going to change that to a vector, right? And the first component, the first part is your horizontal translation, the second part is your vertical translation, and then you just add that vector. Here's our vector to all the coordinates from your pre-image, and that gives you your image. Right? That's all there is to it. I don't think I have too many more examples. There aren't too many ways I can do the same thing. Here we have a rectangle. We want to find the coordinates of the image, J, K, L, M, after the translation, and then we'll draw the image. And we're going to use a matrix. And I think I only had the 1 in your notes. If I'm wrong, you can always add it. All right, so as a vector, x, y goes to x minus 2, y plus 4 is going to be -2, +4. Right, and that's what we're going to add to each of our x coordinates and each of our y coordinates, and then we'll have our points for our image. And I'm just waiting for the rest of my matrix to come up. I just drew part of it, and I don't know where it is. And we have J prime, K prime, L prime, M prime. Boop, boop. There we go. All right, so we have 1 plus -2 is -1. 3 plus -2 is 1, and we have just 2 of the same thing. And then 1 minus 2, that's still -1. And 1 plus 4 is 5, and 5 again. And 4 plus negative 4, that's going to be 0, both of those. And now we graph. Right, so J prime is at negative 1, 5, and it just fits. K prime is at 1, 5. L prime is at 1, 0. And M prime is at negative 1, 0. And I should write those in. So this one is J prime, K prime, L prime, M prime. My K looks really weird. Looks like 1D. There we go. And that was K prime. All right, and so now we'll just connect our points. And then we have our image. There it is. All right? And every point on our pre-image moved the same distance and in the same direction to give us our image. And so you need to be able to use all the different representations. So the graph, the matrix, the coordinate notation, and the vector notation. And then you've got it all. All right, so ABCD has vertices as shown. We're going to graph its image using xy goes to x plus 6y. Right? And so that is the vector 6, 0. Did I write a 0 in there? There we go. How about the end of my vector there? There we go. All right, so we're going to put A, B, C, D. We're going to write those down. And A is located at negative 2, 4. And let me also note. Okay, so X is in top and Y is in the bottom. B is located at negative 5, 2. C is located at negative 4, negative 2. And D is located at negative 1, 3. And we're going to add our vector. And so that's going to be 6, 0. So that means that our y coordinates are not going to change at all. Just our x coordinates. And we're just going to move it 6 to the right, 6 in the positive direction horizontally. All right, so negative 2 plus 6, that's 4. So I might have two equal signs there. Negative 5 plus 6 is 1. Negative 4 plus 6 is 2. And negative 1 plus 6 is 5. And then the y coordinates don't change, so that's 4, 2. My shadow's in the way, negative 2, 3. All right, and so now we can graph this. All right, so we have 4, 4. And that's right here. And 1, 2. And that's right here. 2, negative 2 is over here. And 5, 3 is over here. Right, and now we just connect. Right, so A prime to B prime, B prime to C prime. That's a pretty straight line. C prime to D prime was a very straight line. And A prime to D prime. Right, and so we have the same figure as well as I can draw it. And now it's just moved in our coordinate plane. It's moved 6 in the positive direction, or 6 to the right. Or it's moved using the vector 6, 0. Right? And so that's the same vector has been applied to every one of our points. Right? And that's the vector right there. 6, 0. Okay. I think this might be the last one. We're close to it. I have one more, and then maybe this is the last one. This is the last one. As soon as it comes back. Okay. All right, so we're going to graph that using our rule and coordinate notation. XY goes to x plus 7, y minus 3. All right, so we need to write down the coordinates first, A, B, C, and D. And the matrix to represent our x and y is going to be negative 5, 1. B is at negative 3, 2. C is at negative 1, 1. D is at negative 3, 5. Right, and then we're adding our vector, which is 7, negative 3. Right, and then when we add that, we have A prime, B prime, C prime, D prime. Right, and so we're just going to add 7 to all the x coordinates, negative 3 to all the y coordinates. So negative 5 plus 7 is 2, negative 3 plus 7 is 4, negative 1 plus 7 is 6, and negative 3 plus 7 is 4 again. And 1 plus negative 3 is 2, 2 plus negative 3 is negative 1, 1 plus negative 3 is negative 2, and oops, he's supposed to be a negative 2. And that thing is a 5. 5 plus negative 3 is 2. There, did I add everyone? Every time I walk in front of the screen, I block the information. I block the board, and so then I can't read. And it looks okay right now, I think. All right, so let's put our points. Let's graph our points, and then we'll know for sure. All right, so 2, negative 2 is kind of right in the middle of my matrix, and so I should have chosen a slightly lower spot. Here, try to move everybody down just a little bit. Of course, the negative 3's got to stay. There we go, everybody's moved. Move down this vector. There we go. And then, how hard is it going to be to move this? They're all going to move in little pieces. There goes the x. There goes the y. There goes A, B, C, D, and the rest of the matrix. There we go. Now my poor little figure's not crowded. All right, so 4, oh, and then negative here goes with the 2. 4 negative, come on. 4 negative 1 is B, and there's just no way I'm going to move that negative down. So we'll give it one more try. Here, there's your negative. All right, so continue graphing. Just know there's a negative there. So we have, and we've already graphed that point anyway. There it comes. 4 negative 1 is going to be B prime. Oops, I used a different color for some reason. And then we have 6 negative 2. Right there is C prime. And then 4, 2 is D prime. And then we'll connect. Make sure you connect them in order. Right? So A prime to B prime to C prime to D prime, and D prime goes back to A prime. And there we go. Right? So we've used a matrix, a vector, and a matrix to translate our figure. And that's the last one. Right? So if you have any questions, let me know. And thanks for watching my podcast on translations. Bye for now.